Welcome to day 18 of 100 Days of Code in IoT Challenge. I'm Thomas, and today I'm going to start a new subject on ESP8266 that is a file system. So the next few videos are going to be about that. We're going to be doing things like creating files, reading from the files, writing to files, uploading the files from the computer to ESP8266, downloading the files from the internet, using the certificate store with HTTPS client, and parsing JSON. For today's video, we're going to do the very basics. So I'm going to give you a quick overview about the file system, the persistent storage on ESP8266 itself, and then we're going to move to creating the file, writing to file, and reading from the file in a few different ways. So let's just start. So we're going to start from going through the official ESP8266 documentation on the file system, right? I put the link in the description if you want to go through it yourself, but yeah, I'm just gonna quickly do it here on this video. So yeah, essentially the persistent storage on ESP8266 is a flash memory, and for our model Node MCU 1.0, it is 4 megabytes of memory, of flash memory. You cannot really use all 4 megabytes for the file system, because there is also memory allocated for other things. And those other things are the sketch, which is essentially the compiled code that we send to the device. We have OTA updates, where OTA stands for over the air. So that is used for updating the board, sending the code to the board over the Wi-Fi. There's going to be a separate video on that topic. And we also have stuff like system files, Wi-Fi config, and this EEPROM, which is a specific type of read-only memory that shouldn't be written too often. So that's more like config files. Right. The way this works on PlatformIO, let me show you quickly. Here is another website that is the official PlatformIO documentation. I have also enclosed it in the description of the video. And here what we are interested in is a flash size. So flash size is this option in the platformio.ini file in the project. As a default, it is set to Eagle Flash 4M LD. That means we have up to 4 megabytes of memory allocated for the file system. However, as I said, there is some memory allocated to other things. So this is gonna be the maximum amount you can get to write to the file system. If you go to the GitHub here for the Eagle Flash memory, the 4 megabytes one, this is important actually, because those I don't think the other ones would work for ESP8266, the model we have. So let me show you an example. So if you decide to go for 2 megabytes, for example, this is how the memory is allocated. So there is empty, 1 megabyte empty, 1 megabyte for sketch. That's always the case, that it allocates 1 megabyte. And for SPIFs, which is the file system, it is 2 megabytes. So you're probably wondering why to specify less memory than the one that is available. And the reason simply is, if you decide to upload the files from your system, from your computer, and you choose 4 megabytes, it's gonna take longer. It's gonna take 4 times longer than 1 megabyte, regardless of the amount of data you're trying to send to the device. So that might be a reason why, the speed of deployment, of uploading the files. Okay, so that is on the amount of memory, the configuration on this itself. I think that it is also possible to override. You can override the settings, but for that you need to dig deeper in the documentation. So if you're interested in that, you can simply follow that link and have a look how to do it. Right. Yeah, and as I said, this is the default option, so we don't need to specify anything because I'm simply gonna go with 4 megabytes for today's project. Okay, so now I'm gonna go back to the file system and quickly talk about the file system types. So two general types we have is SPIFs and little fs. There's also SDFS and SD, but these are legacy for the built-in Flash file system. This is mainly used if you have external component where you can connect the SD card and read from SD card. It supports FAT file system, right? So I'm not gonna really talk about those two, but these two, right? There is for the SPIFs. SPIFs used to be the default one. However, it is a bit old and slow, and it doesn't really support directories. And as you can see, it is deprecated now. So little fs is recommended one. On the differences between those systems, the only advantage of SPIFs is the fact that it needs minimum 256 bytes memory allocation to work. So it can work very well on the older Arduino boards, right? Where the memory is very limited, is scarce, very limited, comparing to what we have on ESP, for example, where you see little fs actually needs 4 kilobytes instead, right? So that might be an issue on the older boards. Right, and this is the only advantage, and all the other factors actually are better on little fs. So things like folders, speed, little fs is much faster than SPIFs itself. Yeah, if you're interested in the exact differences, I really recommend going on this website and reading all of those sections here on the limitations and so on. Right, but yeah, on the theory side, that's gonna be everything from me. Now we're going to move to the practice. So let's open Visual Studio Code. We're gonna start from creating a new project today. So PlatformIO section, open, and then new project. The project name is going to be File System, since I'm gonna be playing around with file system, right? And the model is Node MCU 1.0, framework Arduino. Finish. Okay, in the newly created project, we're gonna wait a little bit until the PlatformIO.ini configuration file is opened. And in this file, I'm gonna start from defining the monitor speed. And that's gonna be 115200. And then we don't need to specify the amounts of memory. I'm just gonna go for the default one, which is the 4 megabytes for the file system. However, because I would like to use little fs instead of SPIFs, I'm gonna have to specify that option, which is board build file system equals little fs. Yeah, unfortunately, little fs is not the default one on PlatformIO. The reason is mainly the backwards compatibility, so we need to define it ourselves, and that's what I'm gonna do here. But yeah, that's essentially it. It just needs this option to be defined and monitor speed. And that's it for the configuration. Okay, and now I'm gonna open main.cpp and let's think about the exercise that I'm going to do right now. So yeah, I guess like the simplest example, the simplest usage of little fs, which I need to include, by the way, is going to be opening the file for write in the setup, maybe checking first if the file exists, and only if it doesn't exist, I open it for write, I write some information to it, close the file, and then in the loop I open it again, but for read this time, and I'm just gonna print the contents of the file. So we see if the file has been written to, and also because we check the existence in the setup, when I restart the device, it's not gonna do it again, right? I mean, it shouldn't write to the file again because the file should be there from the last run. But yeah, let me show you how this is gonna look like in the code. So yeah, we've got littleFS included, and now I need to essentially start using it. That allocates all the required memory. So we need to call begin. And when you finish working with the file system, you need to call end. And that's something we're gonna have in the setup and in the loop. Right, so we're gonna start for the if statement to check if the certain file exists. That certain file I'm going to specify the name for. So yeah, I'm gonna declare a variable and assign something like /example. Maybe that's gonna be the file name. So we're checking if the file name doesn't exist, right? If it doesn't exist, then we want to open it. This is gonna be very much like in C. The only difference is you need to call a static method on littleFS. But then it's pretty much the same. So we need to specify the file name and the flag, which is going to be W for writing. Then we can do a check, because if the file is false, we should print something out like could not open the file for writing, maybe, right? Okay, and that should be it, right? I'm going to say return, that's it. I should close the littleFS maybe right after that. So we're sure the memory is released, right? Okay, and then if everything was fine, I'm just going to call file write. So there's going to be the method to actually write something to the file. You can also use print. I've seen on the examples on the internet that some people use print. I'm just going to go for write. They're really pretty much the same. There's lots of overloads, so you can use different types of the argument you provide. And here I'm just going to say like hello and new line. And I'm going to do another write. I am example file content, and then new line. Right, and after that I'm going to close. But before we move to the loop method, let me just show you how can we make sure that we have written to the file. So this method write returns the amount of bytes that has been written to the file. So if I specify a variable and assign the value from the write here, I can essentially do something like that. Maybe bytes written, and that is going to be D, because I think this is unsigned int, and that's what I'm going to provide to the printf. Also a new line so we can see. And based on the bytes written, we could do something like if bytes written equals 0, right? Even though we specified something that is like 7, right? 7 bytes. We can essentially, again, like could write to the file, something like this. We can specify a message, print it out. But that shouldn't really happen, right? Okay, it is also important to close the file. Okay, and now to the loop function. So on the loop function, we're going to be reading from the file instead. So that is going to be quite similar. So file equals littleFS open, and again file name and R instead of W. So that is the difference. We open it for reading. And then there is one very simple method that we can use to read the entire content of the file, which is read string, that returns a string, and we can print this out straight away. What would be nice though here is to specify some delay, like for 5 seconds, right? So we're gonna keep reading from this file every 5 seconds. Yeah, the file close is also important here, right? So we close it before finishing the little fs usage. Okay, so that is the simplest example, and now I'm going to compile it. However, I've just realized I need to specify serial begin and specify the speed on the serial port, right? That is very important. And I'm just thinking what else I could do is to put like 5 seconds delay at the beginning, so the IDE will be able to catch up with the board on the information sent over the serial port. Okay, so now I'm compiling, and let's see what we get. Okay, let me connect to the serial monitor. And that's what we got, right? Hello, I am an example file contents, and again, and again. Cool. Great, so that works. But let me just put another print out here. File does not exist, creating. Something like that. And now I'm going to deploy it again, and we will see if the code in the setup is going to create another file, or maybe the file already exists, right? Because we've just created it in that sketch before, the one that I just deployed and we see the output from. So yeah, deploying again. Okay, connected to the serial monitor, and let's see what we get. Okay, we just got hello, I am an example file contents. So apparently the file does exist, right? Let me restart. Yeah, definitely the file already exists, right? What if I disconnect the device from the USB? So now there is no power supplied to ESP. I'm gonna reconnect it and just quickly open the serial monitor, and let's see if the file exists. It does exist, right? So essentially the sketch memory has nothing to do with the file system memory until you either format it or like upload a new image, or you change the file system itself here back to SPIFs, for example, right? So once we saved something on the flash memory on ESP, it is going to stay there. If I wanted to remove the file, I would have to do something like little fs remove and then specify the file name. Let me just do it, and I'm gonna show you that we will get the file does not exist creating if I do that. Okay, so as you can see, now we got file does not exist creating. If I restart, we should get it again, right? Because it removes the file at the beginning, right? So yeah, you see it does not exist creating bytes written 6, and then it just continues reading from the file. Okay, so that is the simplest example. One extra thing I would like to tell about the reading from the file. It is also good practice for the error handling to have the if statement check on the file, right? So if it doesn't exist, it is good to actually handle the error here, right? That's one thing that we could do. For the read string, this is not really gonna return anything, any error. If the file is empty, it's just gonna return empty string, right? Okay, so that's it for the simplest example. But let's consider the case where we have a file that has lots of data. And by lots of data, I mean more data than the RAM memory on the device itself. So I'm just thinking, let's do it. Let's just modify this code here a bit. So this is essentially gonna remove it. But you know what? Maybe I don't remove it and I specify a different file name. Example big. So that's gonna be bigger file. And I'm gonna use the for loop to, it's gonna start from hello, but in the for loop, I'm going to run it for, let's say, 3,000 times. And this 3,000 times, I'm going to write something like, I am example content, but few times. So we'll have like maybe 100. This is 105. So 1, 2, 3, 4, 5. Something like this. Yeah, okay. Maybe 2 dots instead, right? So we have 100 bytes here, 3,000 times. Because this loop is gonna run for a while, and we don't want to watchdog to restart the device, I'm gonna have to call the yield function. Essentially, what this is gonna do is going to, on every loop iteration, let the device do some housekeeping, something like, you know, dealing with the packets on the network when the Wi-Fi is on, or other stuff that are needed for the board to work. So I'm gonna use that, and maybe another write at the end, just to indicate this is the last line, right? So we know we have the last line here, and yeah, that's it. Maybe also for the visibility purposes, let's print ln I here so we can see while the file is written to. Right, so this is essentially what we're gonna do. We're gonna create a big file, write a lot of information to it, and then I'm gonna keep this code as it is and try to read everything at once. And let's see what happens. So deploying now. Okay, that's deployed. We have serial monitor. We should see lots of numbers soon. Okay, so now it's writing. And as you can see, we got some data and there is an exception, right? And there is an exception. I think if I increased it even more, like to 5,000, for example, we would probably got the error straight away. Let me just do a simple check. Yeah, that's not gonna work. That is not gonna work because the file is already created. So what I need to do is to remove it here. So we should get a fresh file. This time is gonna be bigger, 5,000. Because I would really like to show you that it fails straight away, right? Because it's not possible to assign such a big value, such a big string to a content. It is not possible because we're running out of memory. Okay, let's see again. Okay, we got 5,000. Okay, nothing really happened. right? Probably the device hanged or something like this, or we didn't get anything. You see? So anyway, the point I'm trying to make here is we shouldn't do such a things, right? Here on the limited memory environment. And the simplest way to prevent this kind of situation, let me just decrease this maybe to 2000. So it's not going to be too big. And essentially, yeah, to prevent this sort of situation, there are two techniques we can use. So one, with using the string, that's very simple one, which is using a while loop and calling the file available in the while, and then here getting the content. This is gonna be more like a buffer, and using read string until a terminator symbol, a terminator character, which is going to be a new line. So with this technique, what we could do is to just read one line at once, right? So for that, I can just print this line here in the loop. And with this approach, it is not going to fail, right? Because we just keep reading. I might need to call yield here because that's gonna be very. This is gonna be very long. It's gonna take lots of iterations. But yeah, let's give it a go now. Okay, connected to the serial monitor, and we should see soon. Yeah, okay, that's writing to the file. It is less now, so okay, and we get the contents straight away, right? That's gonna take a while because it's lots of lines, but essentially that works now. Okay, and this is the last line, right? So that works. It's gonna start again in a few seconds. So yeah, I'm going to actually terminate this task. But yeah, so that is one option, right? But what if you don't have a new lines? What if an entire file is in a single line? What to do in that case? So yeah, in that case, what we could do, let me just remove the remove, because now we've got the file already created on the file system, so we can just read from it. So yeah, for that we cannot really use the string until we know what is the structure of the file. If we know there is a certain character inside the file that is the file is structured in some way, there is this character by which we can split it into smaller parts. We could do that, right? But if we don't know, the only way is to change that method. So instead of reading string, we're gonna have to specify a buffer as a char array. So let me do that here, and then there's gonna be completely different methods that we're gonna have to use, which is called read bytes. Read bytes. You can also do read bytes until if you want. I'm just gonna go for read bytes, and for that, what I'm gonna have to specify is the buffer itself, and then the length. And for that, I'm gonna have to use size of this buffer and -1, right? So that's gonna let us read the information from the file. However, if I just go ahead with this, then we're going to get some wrong information. I'm not sure why this is exactly happening. So, that would be file contents, but with some weird symbols. To prevent this kind of situation, there is a very easy step that can be done, which is simply defining a variable and assigning the value from read bytes. That gives us the number of bytes that's been read. And what we want to do is for the buffer, at exactly the point on the bytes read, we want to add a termination symbol, the end of the char string. If we do that, then this is gonna work, but instead of println, I'm gonna do print. The reason I'm doing print is if you do read string until, it's not gonna read the symbol, the terminator symbol you provide. So if I provide a new line, read until doesn't read the new line. I need to add it myself. If I read bytes, that's gonna include the new line as well. So I don't need to do serial println, because if I did, then we would have two enters, two new lines in the output. But yeah, for the entire thing to work, this is enough, right? So we have a buffer, and that buffer is basically written to from those bytes. It reads from the file and writes to the buffer, and we just print what is on the buffer. Okay, so yeah, let's give it a go. Okay, as you can see, we got IM example file content. It is reading. Let's wait until the end. This is the last line, right? So that works as well. The same way the one with until. So these are two methods that you can use to read the big files, right? The one with the string, but for this you need a termination character, and the one without termination character based on the buffer. Cool. Okay, so yeah, that's it in terms of reading and writing to the files that I prepared for you today. Tomorrow, I'm gonna show you how to read the files from the internet. So essentially, download the file and write it to file system, store it on the file system of the microcontroller. And that's it for today. Thanks for watching. Tomorrow I'm going to show you how to download the file from the internet on ESP8266. I'm going to use HTTP protocol first, day after HTTPS secure way. If you like my content and you want to stay up to date with my channel, hit that subscribe button so you will get notification as soon as I upload the next video. Thanks for today and see you tomorrow.